The Rosetta mission, landing on a comet. In November of 2014, after a journey spanning a decade and nearly 4 billion miles, the European Space Agency's Rosetta spacecraft accomplished an incredible feat: it landed on a comet. The Rosetta mission was a groundbreaking achievement in space exploration, and it continues to provide valuable data and insights into the nature of comets and our solar system. The Rosetta spacecraft was launched in March of 2004 with the primary goal of studying comet 67P/Churyumov-Gerasimenko. Comets are remnants from the early days of the solar system, and studying them can provide important clues about the conditions and materials present in the early solar system. After a series of gravity assists from Earth and Mars, Rosetta made its way to its target and conducted a series of flybys to study the comet's surface and composition. In August of 2014, Rosetta made history by becoming the first spacecraft to enter orbit around a comet. But the real challenge was yet to come. In November of that year, scientists and engineers at the European Space Agency embarked on an unprecedented mission to land a spacecraft on the surface of a comet. The landing system for Rosetta was named Philae, after an island in the Nile River where an obelisk bearing ancient inscriptions helped unlock the secrets of the Rosetta Stone. Philae was designed to latch onto the surface of the comet using harpoons and drills and provide close-up data to complement the observations made from orbit. The landing itself was a nail-biting operation. The comet's irregular shape and low gravity made it difficult to predict where Philae would come to rest. Additionally, the spacecraft's landing gear was damaged, making the final descent even riskier. Despite these challenges, Philae managed to make contact with the surface of the comet. However, the harpoons failed to deploy, and the spacecraft bounced off the surface, tumbling and spinning. Finally, after 2 hours of uncertainty, Philae came to rest in a relatively sheltered spot on the comet's surface, tilted at an angle and partially in the shadow of a cliff. Over the next few days, Philae transmitted valuable data back to Earth, including images of the comet's surface and chemical measurements of its composition. However, it soon became clear that the spacecraft's position was not ideal for the solar panels to receive enough sunlight, and the batteries would run out of power soon. Philae went into hibernation, but the data it collected has provided valuable insights into the composition and structure of comets. Researchers have discovered organic compounds on the surface of the comet, which suggests that comets may have played a role in bringing water and other essential building blocks for life to Earth. The Rosetta mission as a whole has also yielded important information about the behavior of comets. The spacecraft's observations have shown that the surface of 67P/Churyumov-Gerasimenko is covered in a thin layer of dust and ice, and that the comet is spewing out vast quantities of gas and dust as it approaches the Sun. This outgassing creates a beautiful coma around the comet, which can be seen from Earth and is a testament to the dynamic and ever-changing nature of our solar system. The Rosetta mission has also provided valuable lessons in engineering and project management. Building and operating a spacecraft that can travel for a decade and survive the harsh conditions of space is no small feat. The intricate landing system, which had to work flawlessly on a comet surface with gravity only 1/6 that of the Moon, required incredible precision and attention to detail. In addition, the Rosetta mission was a true international collaboration involving scientists and engineers from across Europe and beyond. The mission's success was due in no small part to the coordination and cooperation of the many individuals and organizations involved. The Rosetta spacecraft was retired in September of 2016, but the data it collected continues to be analyzed and studied by researchers around the world. The mission has reshaped our understanding of comets and their role in the formation and evolution of the solar system. As we continue to explore our celestial neighborhood, missions like Rosetta remind us of the power of human ingenuity and the amazing things we can achieve through cooperation and perseverance. The legacy of the Rosetta mission will continue to inspire future generations of scientists and engineers to push the boundaries of exploration and discovery. Moreover, the Rosetta mission was not just a scientific achievement but also a cultural one. The public was captivated by the mission, following the progress of Rosetta and Philae on social media and through news outlets around the world. The mission's success was a source of pride and inspiration for many people, highlighting the importance of investing in space exploration and scientific curiosity. In addition, the Rosetta mission had a significant impact on the space exploration community. The success of the mission demonstrated the feasibility of landing on a comet and opened up new possibilities for studying these enigmatic objects. In fact, NASA's Stardust mission, which returned samples of comet dust to Earth in 2006, was partially inspired by the Rosetta mission. The Rosetta mission also paved the way for future comet missions, such as NASA's Comet Interceptor mission. Set to launch in 2028, and the European Space Agency's Comet Interceptor mission planned for 2029. These missions will build on the legacy of Rosetta by studying different types of comets and expanding our understanding of the early solar system. Finally, the Rosetta mission has played an important role in promoting international collaboration in space exploration. The mission involved contributions and expertise from dozens of countries, including the United States, Russia, Japan, and China. By working together, scientists and engineers were able to achieve what would have been impossible for any one country or organization. As we look back on the Rosetta mission, we can appreciate the incredible scientific, cultural, and technological achievements that it represents. The mission's success was the result of a decade of hard work, dedication, and cooperation, as well as the many groundbreaking discoveries that have already emerged from its data. The Rosetta mission truly exemplifies the power of human curiosity and the impact that space exploration can have on our understanding of ourselves and our universe. The Rosetta mission has also had a significant impact on education and public outreach. The mission's website provides a wealth of resources for students and educators, including videos, images, and interactive activities that help explain the science and technology behind the mission. In addition, the mission has inspired a new generation of space enthusiasts and scientists. The Rosetta spacecraft and landing system have become iconic symbols of the mission's achievements and have captured the public's imagination. For many people, the Rosetta mission was a source of inspiration and wonder. It demonstrated what can be achieved through scientific curiosity and the power of collaboration and determination. It also highlighted the importance of investing in space exploration and research. As we continue to explore the mysteries of our solar system and beyond, the legacy of the Rosetta mission will continue to inspire and inform our efforts. Whether we are studying comets, asteroids, or other celestial objects, We can learn from the lessons of Rosetta and strive to achieve even greater feats of discovery and exploration. The Rosetta mission is a testament to the power of human curiosity and the potential of international collaboration. By working together, scientists and engineers were able to achieve what would have been impossible for any one country or organization. The Life and Death of Stars, A Journey Through the Cosmos. The universe is a vast, mysterious expanse, full of secrets that scientists are still struggling to unravel. One of the most fascinating mysteries in the cosmos is the life and death of stars. These luminous objects that pepper the night sky can live for millions to billions of years, and they provide the energy that powers the universe. But what exactly is a star, and what happens during its life? Luminous objects that pepper the night sky can live for millions to billions of years, and they provide the energy that powers the universe. But what exactly is a star, and what happens during its life? Time? The beginning of a star. Stars are formed from clouds of gas and dust that are scattered throughout the universe. These clouds, called nebulae, can be as small as a few light years across or as large as the entire galaxy. In these nebulae, gravity pulls the gas and dust together until it begins to form a dense, hot core. This core is the beginning of a star. These nebulae, gravity pulls the gas and dust together until it begins to form a dense, hot core. This core is the beginning of a star. As the core becomes denser and hotter, nuclear fusion begins to occur. Nuclear fusion is the process by which atoms combine to create heavier elements. In the core of a star, hydrogen atoms fuse together to form helium. This process releases huge amounts of energy in the form of light and heat, and is what powers the star for the rest of its life. To form helium. This process releases huge amounts of energy in the form of light and heat, and is what powers the star for the rest of its life. Star life cycles. Once a star begins nuclear fusion, it enters into a period of stable burning known as the main sequence. For stars like our Sun, this phase can last for billions of years. During this period, the star is in a delicate balance between the inward force of gravity and the outward pressure of the nuclear reactions. As a result, the star remains stable, only fluctuating slightly in size and brightness. Is in a delicate balance between the inward force of gravity and the outward pressure of the nuclear reactions. As a result, the star remains stable, only fluctuating slightly in size and brightness. However, as the star begins to run out of hydrogen fuel in its core, it enters the next phase of its life cycle. For stars smaller than about 1.4 times the mass of our Sun, this phase is relatively quiet. The core begins to shrink and heat up, causing the outer layers of the star to expand and cool. The star becomes a red giant, and will slowly shed its outer layers, leaving behind a hot, dense sea. The core begins to shrink and heat up, causing the outer layers of the star to expand and cool. The star becomes a red giant, and will slowly shed its outer layers, leaving behind a hot, dense sea. Known as a white dwarf. For larger stars, the next phase is much more spectacular. When the core runs out of hydrogen fuel, it begins to collapse under its own gravity. This causes the outer layers of the star to collapse until they reach the core. The core then rebounds, creating a massive shock wave that rips through the star, blowing it apart in a cataclysmic event known as a supernova. The explosion is so until they reach the core. The core then rebounds, creating a massive shock wave that rips through the star, blowing it apart in a cataclysmic event known as a supernova. The explosion is so big that it can briefly outshine an entire galaxy, and it releases enough energy to fuse heavier elements such as gold and platinum. After the supernova, the core of the star either becomes a neutron star or a black hole. Neutron stars are incredibly dense objects that are created when the core of a star collapses, but is stopped. Why the pressure of the neutrons? Black holes, on the other hand, are formed when the core collapses under its own gravity, creating a point of infinite density known as a singularity. Why the pressure of the neutrons? Black holes, on the other hand, are formed when the core collapses under its own gravity, creating a point of infinite density known as a singularity. The end of a star. For small stars like our Sun, the end of the star's life cycle is relatively calm. The star's outer layers will shed, leaving behind a hot, dense core known as a white dwarf. This core will slowly over billions of years, until it becomes a cold black dwarf. Over billions of years, until it becomes a cold black dwarf. For larger stars, the end is much more dramatic. After the supernova, the star's outer layers will be blown away, leaving behind only the core. This core can be either a neutron star or a black hole. Depending on the mass of the original star. Neutron stars are incredibly dense, and can spin hundreds of times per second. Black holes, on the other hand, are incredibly fascinating objects that have. Depending on the mass of the original star. Neutron stars are incredibly dense, and can spin hundreds of times per second. Black holes, on the other hand, are incredibly fascinating objects that have. Puzzled scientists for decades. The Life and Death of Stars, A Journey Through the Cosmos. The study of stars is incredibly important to astronomers. By understanding how stars are formed, how they live, and how they die, scientists can better understand the universe as a whole. For example, when stars explode in a supernova, they release huge amounts of energy and heavy elements into the universe. These elements can then go on to form new stars, planets, and even life. When stars explode in a supernova, they release huge amounts of energy and heavy elements into the universe. These elements can then go on to form new stars, planets, and even life. The study of stars is also important because stars are used as cosmic laboratories for studying the laws of physics. For example, scientists can study the behavior of matter at incredibly high temperatures and pressures in the core of a star. They can also learn more about the behavior of gravity in the extreme environments of black holes and neutron stars. Temperatures and pressures in the core of a star. They can also learn more about the behavior of gravity in the extreme environments of black holes and neutron stars. However, despite the incredible advances that have been made in the study of stars, there is still so much that we don't know. There are countless mysteries waiting to be unlocked in the universe, and the study of stars is just one small part of this ongoing discovery. The study of stars is just one small part of this ongoing discovery. As our technology advances, it is likely that we will continue to uncover new and exciting information about stars and the cosmos as a whole. The future of astronomy is incredibly exciting, and there is no telling what we might discover next. In the meantime, the study of stars continues to captivate and inspire scientists and astronomers around the world. Whether it is through the use of telescopes, satellites, or other cutting-edge tech. Ology, our quest to understand the mysteries of the universe will never end. The universe is vast and full of wonders, and our exploration of the stars is just the beginning of this incredible journey. Ology, our quest to understand the mysteries of the universe will never end. The universe is vast and full of wonders, and our exploration of the stars is just the beginning of this incredible journey. As we continue to uncover more about the life and death of stars, it is important to remember the significance they hold in our understanding of the universe. From their creation in clouds of gas and dust to their explosive end as a supernova or the birth of a black hole, stars are a powerful force in shaping the cosmos. Dust to their explosive end as a supernova or the birth of a black hole, stars are a powerful force in shaping the cosmos. As we look up at the night sky, we are seeing countless stars that each have their own unique story. Some may be young, only recently formed and not yet burning brightly. Others may be massive, on the verge of exploding in a fiery supernova. And still, others may be fading away, their light slowly extinguishing as they become a cold black dwarf. Verge of exploding in a fiery supernova. And still, others may be fading away, their light slowly extinguishing as they become a cold black dwarf. The fate of the universe, Big Rip, Big Crunch, or slow fade? The universe has been a source of wonder and contemplation since the beginning of time. People have always asked themselves about its origins, its structure, and ultimately, its destiny. The question of the fate of the universe is one that still puzzles scientists and philosophers alike. Will the universe continue to exist indefinitely, or will it eventually come to an end? If it does come to an end, of the fate of the universe is one that still puzzles scientists and philosophers alike. Will the universe continue to exist indefinitely, or will it eventually come to an end? If it does come to an end, what will be its ultimate fate? There are different theories regarding the fate of the universe, and this article will explore the most prominent ones: the Big Rip, the Big Crunch, and the slow thaw. The Big Rip theory predicts that the universe will continue to expand at an accelerated rate until the gravitational force between galaxies weakens to the point where it can no longer hold them together. Eventually, the expansion will be so fast that even individual galaxies will begin to disintegrate due to the force of dark energy, a hypothetical form of energy that is thought to be responsible. Eventually, the expansion will be so fast that even individual galaxies will begin to disintegrate due to the force of dark energy, a hypothetical form of energy that is thought to be responsible for the acceleration of the universe's expansion. At some point, the fabric of spacetime itself will be subjected to the force of dark energy and torn apart, resulting in an event known as the Big R. The idea of the Big Rip was proposed in 2003 by Robert Caldwell, Mark K. Minkowski, and Nevin Weinberg. They based their theory on the observation of distant supernovae, which showed that the universe's expansion was accelerating. The Big Rip has been described as the ultimate fate of the universe, and if it were to happen, it would mean that everything we know, every star, every planet, and its expansion was accelerating. The Big Rip has been described as the ultimate fate of the universe, and if it were to happen, it would mean that everything we know, every star, every planet, and every atom, would be torn apart. The Big Crunch theory, on the other hand, proposes that the universe will eventually stop expanding and begin to collapse inward under the influence of gravity. As the universe gets denser, it will become hotter until it reaches a point of maximum density and temperature known as the Big Crunch. At this point, the universe will collapse into a single point, known as a singularity, just as it was. Come hotter until it reaches a point of maximum density and temperature known as the Big Crunch. At this point, the universe will collapse into a single point, known as a singularity, just as it was. During the Big Bang. The Big Crunch theory was first proposed in the 1920s by Sir James Jeans, who suggested that the universe would eventually collapse due to the pull of gravity. The idea was later refined by Georges L. Mater and was a popular theory before the discovery of dark energy in 1998. The discovery of dark energy showed that the universe was not only expanding, but that the rate of expansion was increasing. Mater and was a popular theory before the discovery of dark energy in 1998. The discovery of dark energy showed that the universe was not only expanding, but that the rate of expansion was increasing. Over time, this discovery led to the development of the Big Rip theory and caused the Big Crunch theory to fall out of favor. Finally, the slow fade theory proposes that the universe will continue to expand at a gradually decreasing rate until all the stars and galaxies have been depleted of their fuel. As the last stars boo and out, the universe will enter a state known as the heat death, where the universe will become a dark, cold, and lifeless void. The slow fade theory is based on the second law of thermodynamics, WH. And out, the universe will enter a state known as the heat death, where the universe will become a dark, cold, and lifeless void. The slow fade theory is based on the second law of thermodynamics, WH. CH states that in a closed system, entropy will continuously increase, and all energy will eventually be evenly distributed. The slow fade theory was first proposed by Lord Kelvin in the late 1800s and predates the discovery of the Big Bang. The theory gained popularity in the 20th century and has been supported by various observations, including the cosmic microwave background radiation. The slow fade theory proposes a more gradual end to the universe than either the Big Rip or the Big Crunch, but it still predicts observations, including the cosmic microwave background radiation. The slow fade theory proposes a more gradual end to the universe than either the Big Rip or the Big Crunch, but it still predicts arc and lifeless future for the cosmos. So, what is the fate of the universe? The truth is that nobody knows for sure. Each of these theories presents a different scenario, ranging from a dramatic, cataclysmic end to a slow, gradual decline. What is clear, however, is that the universe is constantly changing and evolving. The discovery of dark energy in the late 1990s was a game changer in our understanding of the universe and has led. What is clear, however, is that the universe is constantly changing and evolving. The discovery of dark energy in the late 1990s was a game changer in our understanding of the universe and has led. New and exciting theories about its future. Despite the uncertainty about the fate of the universe, scientists continue to study and explore the cosmos, searching for answers to our most fundamental questions about the universe's origins, its structure, and its ultimate destiny. One thing is certain: no matter what the universe's ultimate fate may be, our small planet, our fragile existence, and our complex civilization will continue to structure and its ultimate destiny. One thing is certain: no matter what the universe's ultimate fate may be, our small planet, our fragile existence, and our complex civilization will continue to They evolve and thrive under its vast and mysterious canopy. As we continue to learn more about the universe, we are constantly humbled by its magnitude and intricacy. We have discovered countless galaxies, stars, and planets, each with its unique story to tell. From studying the smallest subatomic particles to observing the largest structures in the universe, scientists have worked tirelessly to unravel the mysteries of this vast and awe-inspiring system. From studying the smallest subatomic particles to observing the largest structures in the universe, scientists have worked tirelessly to unravel the mysteries of this vast and awe-inspiring system. One of the most exciting developments in recent years has been the rise of space exploration. With the advent of advanced technology, we have been able to send probes and rovers to explore other planets and asteroids, giving us a more comprehensive understanding of our solar system and the universe at large. And asteroids, giving us a more comprehensive understanding of our solar system and the universe at large. However, space exploration is not without its challenges, both technical and ethical. There are concerns about how our exploration might impact the celestial bodies we encounter. Some worry that we inadvertently introduce bacteria or other organisms to these places, potentially harming any extraterrestrial life that might exist there. Inadvertently introduce bacteria or other organisms to these places, potentially harming any extraterrestrial life that might exist there. There are also concerns about the safety of space exploration. Space travel is inherently dangerous, and we have seen tragic accidents in the past, such as the Challenger and Columbia disasters. We have made great strides in making space travel safer. There is always the risk of technical failure, and some argue that we should focus on addressing problems on Earth rather than exploring the. We have made great strides in making space travel safer. There is always the risk of technical failure, and some argue that we should focus on addressing problems on Earth rather than exploring the. Cosmos. Despite these concerns, there is no doubt that space exploration has helped us gain a deeper understanding of the universe. It has allowed us to see firsthand the stunning beauty and diversity of our planets and asteroids. We have discovered unexpected phenomena, such as black holes and gamma-ray bursts, and have been able to conduct experiments that would be impossible on Earth. Our planets and asteroids. We have discovered unexpected phenomena, such as black holes and gamma-ray bursts, and have been able to conduct experiments that would be impossible on Earth. As we continue to explore the universe, we must do so carefully and thoughtfully. We should be conscious of the impact our exploration might have on other celestial bodies and should work to minimize any harm we might inadvertently cause. At the same time, we should continue to pursue our exploration and study of the cosmos, as it is through our understanding of the universe that we gain a more any harm we might inadvertently cause. At the same time, we should continue to pursue our exploration and study of the cosmos, as it is through our understanding of the universe that we gain a more profound understanding of ourselves and our place in the world. Another exciting development in recent years is the discovery and study of exoplanets, or planets that exist outside of our solar system. With new methods and technology, scientists have been able to the zodiacal light, a mysterious glow in the night sky. The night sky has always been a source of fascination for humans. From the stars to the galaxies, there are many mysteries and wonders to behold. One particular phenomenon that captures the imagination of astronomers and stargazers alike is the zodiacal light. The zodiacal light is a faint, hazy band of light that can be seen in the night sky. It appears as a triangular-shaped glow that extends from the horizon up to the sky's apex. This glow is most visible just after sunset or before sunrise, and it can be seen in areas with little to no light pollution. The zodiacal light is caused by the scattering of sunlight by small dust particles that are present in the inner solar system. These dust particles are believed to be remnants of comets and asteroids that have been broken up over time. As the dust particles scatter the sunlight, they create a diffuse glow that appears as the zodiacal light. The name zodiacal light comes from the fact that it is seen along the path of the zodiac, which is the band of constellations that the sun, moon, and planets appear to travel through as seen from Earth. The zodiacal light is brightest near the sun and fainter as it extends away from it, giving it the triangular shape. The zodiacal light was first described by the ancient Greeks, who believed it to be a band of light created by the goddess Eos, the goddess of dawn, as she drove her chariot across the sky. Later, the phenomenon was described by the astronomer Giovanni Domenico Cassini in the 17th century. Despite being known for centuries, the zodiacal light remained a mystery for many years. It wasn't until the 19th century that scientists were able to explain the phenomenon through the scattering of sunlight by dust particles. Today, we have a better understanding of the zodiacal light, thanks to advances in technology and our ability to observe it from space. One of the most fascinating things about the zodiacal light is that it is a sign of our place in the universe. It reminds us that we are part of a vast, interconnected system of planets, stars, and galaxies. As we gaze up at the zodiacal light, we are reminded of the wonders of the universe and our place within it. The zodiacal light is not only a reminder of our place in the universe, but it is also a valuable tool for astronomers. By studying the zodiacal light, scientists can learn more about the dust particles that are present in the inner solar system. These dust particles can tell us about the origins of our solar system and how it evolved over time. In addition to being an important scientific tool, the zodiacal light is also a beautiful sight to behold. Many people travel to dark sky locations to view this phenomenon, and it has become a popular subject for astrophotographers. Capturing the zodiacal light on camera requires patience, skill, and a bit of luck, but the results can be stunning. Despite being a mysterious and awe-inspiring phenomenon, the zodiacal light is often overshadowed by other celestial events, such as meteor showers and eclipses. However, it is a reminder that there is still so much to explore and discover in our universe. As we continue to study the zodiacal light and other phenomena, we will undoubtedly uncover new mysteries and wonders that will capture our imagination for generations to come. As we continue to study the zodiacal light, we are learning more about our solar system and how it came to be. One theory is that the dust particles that create the zodiacal light are remnants of the process that formed the planets. As the sun and planets formed, they created a disk of gas and dust around them. Over time, this disk began to clump together, forming the planets we know today. However, not all of the dust in the disk was used up in this process. Some of it remained scattered throughout the inner solar system, where it continues to create the zodiacal light. Studying the dust particles in the zodiacal light can tell us more about the elemental composition of our solar system. By analyzing the spectra of the light, astronomers can identify the chemical elements present in the dust particles. This can give us clues about the conditions that existed during the formation of our solar system. In addition to the zodiacal light, there are other sources of cosmic dust that can be studied. For example, meteorites that fall to Earth contain small particles of dust from space. By studying these particles, scientists can learn more about the makeup of asteroids, comets, and other objects in the solar system. The study of cosmic dust has implications beyond our solar system as well. Dust is present throughout the universe, and it plays an important role in the formation of stars and planets. By studying dust particles in other galaxies, we can learn about the conditions that existed during the formation of those galaxies. This can give us a better understanding of how galaxies form and evolve over time. In addition to its scientific value, the zodiacal light holds cultural significance as well. In many cultures, the zodiacal light is associated with the afterlife or the spirit world. In parts of China and Vietnam, it is believed that the zodiacal light is a bridge that the spirits of the dead must cross on their way to the afterlife. In Japan, it is believed that the goddess Izanami created the zodiacal light as a sign of hope for those who have lost loved ones. Whether viewed as a scientific phenomenon or a cultural symbol, the zodiacal light continues to capture our imagination and inspire wonder. As we gaze up at the night sky, we are reminded of the vastness and complexity of the universe, and the many mysteries that are left to be discovered. As technology advances and our understanding grows, we are sure to uncover more wonders and more mysteries, and the zodiacal light will continue to be a source of inspiration and fascination for generations to come. The zodiacal light is not the only celestial event that captivates the attention of stargazers. Other phenomena such as auroras, also known as the northern and southern lights, are some of the most breathtaking natural wonders that can be seen in the night sky. Auroras are a result of charged particles from the Sun colliding with particles in Earth's atmosphere. These collisions create a dazzling display of light that can be seen in areas close to the Earth's magnetic poles. Another event that garners a lot of attention from stargazers is the Perseid meteor shower. The Perseids are one of the most active meteor showers of the year, occurring annually in mid-August. The art of astrophotography, capturing the beauty of the night sky. The night sky has always captivated human beings since the beginning of time, with its stars, galaxies, and other celestial wonders. Astrophotography, the art of capturing images of the night sky, has allowed us to not only capture its beauty but also to study and understand the mysteries of the universe. Astrophotography requires a combination of skill, patience, and equipment to produce stunning images that showcase the wonders of the universe. With modern technology and equipment, capturing the night sky has become more accessible, allowing anyone with a camera and a tripod to take stunning pictures of the stars. One of the first things to consider when attempting astrophotography is finding a proper location. Large cities and urban areas are filled with light pollution, which can affect the clarity of your images. Head out to a darker region, ideally with minimal light pollution, to ensure you capture the stars in clear detail. The equipment used for astrophotography is also important. A DSLR camera with good low light capabilities is ideal, although a point-and-shoot camera can produce decent results. A tripod is also necessary to keep the camera stable for the long exposure times required for astrophotography. Once you have your equipment ready, it's time to start taking pictures. One of the main things to keep in mind when capturing the night sky is the exposure time. Longer exposure times allow more light to be captured, producing brighter images. However, too long of an exposure time can cause star trails or blur in the final image. The aperture of your camera should be set to its lowest value to allow as much light as possible into the camera. This is typically around f/2.8, but it can vary depending on the camera and lens being used. The ISO setting should also be set as high as possible to capture as much light as possible, while still maintaining acceptable image quality. In general, an ISO setting of between 800 and 3200 is suitable for astrophotography. To capture the stars in motion, it is important to also consider the type of lens being used. A wide-angle lens, such as a 14 to 24 mm, captures more of the sky in a single image, making it perfect for capturing star trails or the Milky Way galaxy. However, if you're looking to capture a single constellation or planet, a zoom lens with a longer focal length may be more appropriate. One thing to consider when photographing the night sky is the weather. Cloudy or overcast skies can prevent you from capturing the stars in all their glory. Checking the weather forecast beforehand can help you plan when to head out to capture the stars. Another important factor to consider when photographing the night sky is patience. Taking stunning astrophotography images takes time and effort, so be prepared for a few hours of waiting for the perfect shot. Even a slight breeze or vibration can affect the quality of the image, so it's vital to be patient and wait for the right conditions. One of the most popular subjects for astrophotography is the Milky Way. The Milky Way is visible with the naked eye from dark locations, but capturing its vivid beauty with a camera is something truly special. Photographing the Milky Way requires a combination of planning, timing, and skill, but the results can be breathtaking. To capture the Milky Way, it's best to head out to a dark location during the summer months. The Milky Way is visible in the northern hemisphere from April to September but is more visible during the summer months. It's important to plan ahead and pick the right time to capture the Milky Way. Another popular subject for astrophotography is the northern lights. The northern lights, or aurora borealis, can be seen in the northern hemisphere during the winter months. Capturing the northern lights requires a bit more preparation, as you need to be in a location that has a clear view of the northern horizon and has low light pollution. One of the best ways to capture the northern lights is to use a wide-angle lens to capture the horizon and the stars above. A longer exposure time is necessary to capture the subtle movement of the aurora, but too long of an exposure time can cause the aurora to become overexposed and lose detail. Astrophotography is a fascinating and rewarding hobby that has allowed us to capture the beauty and mystery of the universe. With skill, patience, and the right equipment, anyone can take stunning images of the night sky. Whether it's capturing the Milky Way or the northern lights, astrophotography is a fantastic way to connect with the universe and explore its wonders. In addition to capturing images of the night sky, astrophotography has also played an important role in scientific research. Scientists use astrophotographs to study the properties of celestial objects, such as stars, galaxies, and planets. By analyzing the images captured through telescopes and cameras, scientists can gain a better understanding of the universe and its origins. One example of the scientific importance of astrophotography is the study of exoplanets. Exoplanets are planets outside our solar system, and their discovery has been one of the most exciting advancements in astronomy in recent years. By analyzing changes in light captured through astrophotography, scientists can detect exoplanets orbiting other stars and gather information about their properties, such as their size and composition. Astrophotography has also been used to study the structure and evolution of galaxies. Galaxies are massive collections of stars, gas, and other matter, and the images captured through astrophotography provide insights into how they form and evolve over time. In addition to photographic techniques, other methods are used to study the universe. One of the most important of these is spectroscopy. Spectroscopy is the study of how light interacts with matter, and it is used to study the composition and properties of celestial objects. By analyzing the colors and patterns in light captured through spectroscopy, scientists can determine the elements present in stars, planets, and other objects in the universe. Another important technique used in astronomy is radio astronomy. Radio astronomy uses radio waves to study celestial objects, and it has played a critical role in the discovery of new objects and phenomena in the universe, such as pulsars, quasars, and the cosmic microwave background radiation. In recent years, astrophotography has become increasingly popular, with many people around the world taking up the hobby. Social media platforms such as Instagram and Flickr are filled with stunning images of the night sky, showcasing the beauty of the universe for all to see. The Galilean moons, life in our own solar system? The Galilean moons are four of Jupiter's largest moons and were first discovered by Galileo Galilei in 1610. They are named after the Italian astronomer and philosopher who first observed them through his telescope. The four Galilean moons are Io, Europa, Ganymede, and Callisto. These moons have become a center of interest for astronomers because of their unique characteristics and potential to support life. Io is the closest of the Galilean moons to Jupiter and is the most volcanically active object in the solar system. Its surface is covered with over 400 active volcanoes, with some erupting lava fountains as high as 300 kilometers. These volcanic eruptions are caused by the intense tidal forces that Jupiter exerts on Io, resulting in its molten interior being stirred up. The surface temperature of Io reaches up to 1,300 degrees Celsius, making it one of the hottest objects in the solar system. Its surface is also covered with sulfur dioxide, sulfur, and other volcanically produced materials. Europa, the second Galilean moon, is considered as one of the most promising candidates for life in our solar system. Europa has a surface that is mostly covered in ice and might have a subsurface ocean of liquid water. Scientists believe that this ocean might contain more than twice the amount of water present on Earth. The ice shell is estimated to be around 15 to 25 kilometers thick, and the ocean below might be 100 kilometers deep. The presence of liquid water on Europa, along with its geothermal energy, makes it an ideal location for extraterrestrial life. Ganymede is the largest moon in the solar system and is also the only known moon to have its magnetic field. Despite its size, it has a low density and is composed mostly of water ice. Its surface has both bright and dark regions, and scientists believe that it has a subsurface ocean that might contain more water than all of Earth's oceans combined. Ganymede's magnetic field might be generated by the presence of its subsurface ocean. Callisto, the outermost Galilean moon, has the oldest surface in the solar system, dating back to over 4 billion years. Its geology is characterized by impact craters, which suggests that it has a relatively inactive interior. Its surface is composed of a mixture of ice and rock, and scientists believe that it also has a subsurface ocean. Callisto's subsurface ocean is expected to be in contact with a rocky core, making it another potential location for extraterrestrial life. The Galilean moons are fascinating objects for scientists as they hold important clues about the formation and evolution of the solar system. These moons are believed to have formed around Jupiter along with several other smaller moons. However, these smaller moons were either ejected away from the Jovian system or collided with the larger moons. One of the most significant discoveries made by space missions to the Galilean moons is the evidence of a subsurface ocean on Europa and possibly Ganymede and Callisto. These oceans hold the key to understanding the potential for life beyond Earth. In the case of Europa, Scientists believe that the ocean might be in contact with its rocky mantle, creating a geothermal system that can support microbial life. The subsurface ocean on Europa has been imaged by the Galileo spacecraft, which observed small fractures on its surface caused by the movement of ice sheets. This observation suggests that there might be hydrothermal vents on Europa similar to those found on Earth's ocean floor. The potential for life on the Galilean moons has made them prime targets for exploration by space missions. Several missions have been sent to study these moons, including the Galileo spacecraft, which was launched in 1989 and arrived at Jupiter in 1995. The Galileo spacecraft studied the Galilean moons in detail, collecting data on their composition, geology, and magnetic fields. More recently, NASA's Juno mission, which arrived at Jupiter in 2016, has also studied Jupiter's magnetic fields and gravity to understand the structure and composition of the planet and its moons. NASA's upcoming mission, Europa Clipper, is specifically designed to study Europa in detail. The Europa Clipper is expected to launch in the 2020s and will study Europa's surface and subsurface, including its ocean. The mission aims to answer critical questions about the potential for life on Europa by studying its geology, composition, and habitability. The Galilean moons are fascinating objects that challenge our understanding of the solar system. The potential for life on Europa, Ganymede, and Callisto has drawn significant interest from scientists who seek to understand the origins of life and its potential beyond Earth. Studying these moons is also crucial to understanding the formation and evolution of the solar system. With ongoing and future space missions dedicated to studying these moons, it is only a matter of time before we learn more about the mysteries and potential of these fascinating objects in our own cosmic backyard. In addition to being fascinating objects for scientific research, the Galilean moons have also captured the imagination of science fiction writers and filmmakers. In Arthur C. Clarke's novel, 2010, Odyssey 2, the main plot revolves around a mission to Jupiter and its moons, including the discovery of a potential alien civilization on Europa. The novel was later adapted into a movie, 2010, The Year We Make Contact, which further popularized the idea of extraterrestrial life on the Galilean moons. The Galilean moons have also been featured in many other works of science fiction, including the popular video game Destiny, where players explore the moons and participate in battles against extraterrestrial enemies. The moons also made a brief appearance in the 2016 film, Independence Day: Resurgence. While these depictions of the Galilean moons are fictional and often portray fictional scenarios, they illustrate the fascination and excitement that these moons hold for both scientists and the general public. From potential alien life to geothermal vents on Europa, the Galilean moons present a wealth of scientific mysteries and opportunities for exploration. Furthermore, the Galilean moons also have practical applications beyond scientific research and entertainment. For example, Ganymede's low-density composition and its potential for a subsurface ocean make it an attractive destination for future human exploration and colonization. The availability of water on the Moon could provide a much-needed resource for future space missions and even serve as a stepping stone for further exploration of the outer solar system. Moreover, the study of the Galilean moons could also have implications for the search for life elsewhere in the universe. The fact that life on Earth relies heavily on liquid water has led scientists to focus on the presence of water on other planets and moons as a key factor in determining their potential for life. The Galilean moons provide a unique opportunity to study the potential for life beyond Earth, given their proximity to our planet and the availability of existing space technology to explore them. Finally, the study of the Galilean moons and the exploration of our own solar system remind us of the vastness and complexity of the universe. The mysteries and potential discoveries that await us in space can inspire us to continue pushing the boundaries of scientific knowledge and technological innovation.